All right, guys, welcome back to the Trig Day 2 notes. I want to scroll down here and show you my work for numbers 5 and 6. If you got these correct, great job. My answer for number 5 was 18.97 degrees. You might notice that I am consistently measuring to the nearest hundredth. I don't know why that skipped there. This answer I got was 54.31. The first one I used sine because I was given opposite and hypotenuse. The second one I was given cosine because I was given adjacent and hypotenuse in comparison to the angle. Feel free to pause the video here if you need to copy any of this down or if your work was incorrect. Please let me know when I see you next if you had any questions about these two problems. Now comes the real fun with word problems. Some of you are probably saying, Mrs. Logus, fun, really? And I say, indeed. So if we take a look at number 7, what we need to do is sketch a picture of what's going on. A ladder leaning against a house makes an angle of 60 degrees with the ground. So, because this is trig, I'm not going to be super special about the drawings. You can be as beautiful as you'd like, but I'm just going to draw right triangles. So a ladder leaning against a house. So I'm going to assume, hopefully, that the house is perpendicular to the ground. And this ladder makes an angle of 60 degrees with the ground. So if this is the ladder, the angle that hits the ground here, that it makes with a little arrow, I'm going to assume is the 60 degrees. So this angle here is my 60. The foot of the ladder is 7 feet from the foot of the house. So whenever you see the phrase foot, that is assuming the bottom of the building. So this length right here is 7 feet. And we'd like to know how long the ladder is. So I'm going to call this unknown piece x. And so what we've really created here is just another triangle that we can use trigonometry to solve once we have the picture correct. So just like before, everything's based on the angle. And yes, this is a 60-degree angle, so let me do it two ways. First, if I was going to do trigonometry, I would say that the 7 is adjacent and this is hypotenuse. So, TOA. A lot of times so far in this video we've ended up using cosine because we're given these two sides. So you would say that cosine of your angle of 60 degrees is the same as adjacent over hypotenuse, or cosine of 60 degrees is really 7 over x. And so if we want to solve this, again we put this over 1, we cross multiply and get x times the cosine of 60 degrees equals 7. We divide by the cosine of 60, because correctly, we can't just divide by 60, because the cosine of 60, as a lot of you recall from yesterday, is really just a fraction or decimal, and it's really a number in itself. So if you take 7 divided by the cosine of 60 degrees, I believe we get a very, very exact answer. I got that the x value was 14, which means that the ladder, because it's a word problem, a ladder is 14 feet, or 14 feet long. Now, some of you might be wondering, Mrs. Logus, could I have just used the 30, 60, 90 triangle? And the answer is yes. Trig is not always the best way to do something. So if you notice that this is a 30, 60, 90, you would know that this side is 7 root 3 and this side is 14, which a lot of you can probably clearly see is a lot faster than trig. But I want to reiterate the point that trig could be used with the special angles, or you could use just the special relationship. Number 8. And after this example, I'm going to have you actually trying to start the diagrams on your own. But this one can be a little tricky. From the top of a tower, the angle of depression to a stake on the ground is 72 degrees. So let me extend this page. And I'm just going to draw a basic triangle. So from a right triangle. From the top of a tower, so again, I guess I'll be a little bit more artistic this time. Not really, though. If I have a tower, from the top of the tower, the angle of depression. Now, here's something I want you to understand about the angle of the depression. It's dependent, or it depends, on the horizontal. So feel free to write that if you would like. Here's what I mean by that. Picture you were standing on top of the building. If you look at the sky, aren't you looking directly across like this? So the angle of depression is dependent on the horizontal. So if I knew eventually I was going to have a little right triangle in this problem, so let's assume again that the building is perpendicular to the ground. A lot of students assume that this right here is the angle of depression, but because it depends on the horizontal, picture yourself standing on the top of this building and you looking out. Your eyesight from the horizontal is going to go down like this. So this actually isn't the angle of depression. This from the horizontal, this is the 72 degrees. And I'm going to write a note that this is the angle of depression. Now, something that really helps, though, is that there's another type of angle called the angle of elevation. And it turns out that the angle of depression and the angle of elevation are alternate interior angles. And from your experience, you know that alternate interior angles are congruent if your lines are parallel. Well, let's assume again that the building is perfectly parallel to the ground in a perfect world. So if this is 72 degrees, I know that this angle inside the triangle, the angle of elevation, is also 72 degrees. Now that helps us a lot, because now if we know that the top of the tower is 80 feet above the ground, I know that this side here is 80 degrees. So if I drew a cleaner triangle, what we have is the 72 degrees in here. We have that this side is 80, and we want to know how far the stake is from the end of the tower, or from the foot again of the tower. Remember, foot again means bottom. So what we're really looking for is the bottom of this triangle here. And so if we use this is the basis angle of 72, it looks like we have opposite and it looks like we have adjacent, which opposite and adjacent lead me to tangent. So we can say that the tangent of 72 degrees equals opposite over adjacent. Tangent of 72 degrees equals 80 over x. So if we solved this, we could cross multiply, right? This is over 1 again, and get x times the tangent of 72 degrees equals 80. Divide both sides by the tangent of 72. And if you take 80 divided by the tangent of 72 degrees, you would get an answer of 25.99 feet. So that means how far is the stake from the foot of the tower? It is 25.99 feet away. This next problem, I would like you to pause the video at this point, and I want to see if you can draw a picture, and then when you come back and check, I want you to see if your picture is the same. And then I'm going to pause the video again and have you try it with the trig. So please pause your video now, and when you come back, I will have my picture ready. Please pause now. All right, guys, so to check back in with you, I had drawn my very beautiful tree. I said that the vertical height of the tree was 40 feet, and make sure that you had your shadow as the horizontal distance, because if you picture yourself walking along the street, your shadow is down here. It is not the hypotenuse, it is right here. So please keep that in mind. If you agree with my angle of elevation, if you were elevating your head, picture again yourself sitting down here, your eyes go up from the horizontal, just like the angle of depression, the angle of elevation also is affected by the horizontal. So this would be your angle. So again, if I drew a neater picture, this is your x value, this is your 40, and this is your 58. So what I would like you to do is try to find your angle by creating your own trig function and trying to solve. So please pause the video now and give that a shot. I'll have the work when you come back. All right, so my final answer was 34.59 degrees was my angle of elevation. To do that, I looked at my triangle, saw that based on the angle here, I had the opposite and adjacent side, which meant my eye went to tangent. So I used the tangent function, plugged in my values. I remembered that the only way to get rid of tangent was to use the inverse of both sides. So in the calculator, remember to press second first, then press the tangent button, and you would have the inverse tan come up like this. You would plug in your ratio, and that angle in degrees would come out. All right, last but not least, we have a problem about a balloon. So let's take the time to set up a picture. A balloon on a 40-foot string makes an angle of 50 degrees with the ground. So you have a balloon. It is a 40-foot string, but the string hits the ground at an angle of 50 degrees, which means the wind is blowing, and it's not, so it can't just be straight down. So if I draw a string that maybe decides to hit the ground at 50 degrees, even though this picture looks strange, picture to yourself that you have a little right triangle here with the string being the hypotenuse. We are saying that the string here hits the ground kind of like an angle of elevation at 50 degrees. We also know that the string itself is 40, so it looks like we really know that the hypotenuse is 40 feet. We want to know how high above the ground is the balloon if the hand of the person holding the balloon is 6 feet above the ground. As a word of advice, let's ignore the fact that this 6 is here, because this is going to come into play at the end once we find how tall the balloon is. Then we can actually find how high the balloon is above the ground with the person holding it. So let's not worry about this till later. So we want to know how high above the ground. So I'm thinking that we are trying to find this height. So again, what I'd like you to do is pause the video, find the height of X. I will come back with the work, and then we will consider this 6 feet. So please pause now. All right, so to check in with you so far, I ended up using the sine function because comparative to this angle here, I had the opposite in hypotenuse. So I said that the sine of my angle was x over 40. I cross multiplied, and I had so far that my balloon was 30.64 feet above the ground. Now, we want to know exactly how high above the ground the balloon is once we also consider that the person holding the balloon is 6 feet tall. So to get the final answer, what we'd have to do is take the 30.64 feet, and if you picture it, there is a person down here really holding the balloon. That is very not to scale. The person looks so tiny and the balloon looks large, but as we've said the whole year, never assume from a diagram. But anywho, you would take the 30.64 feet, you would add that the person is 6 feet tall. So your final answer would be 36.64 feet. That's how high the balloon actually is off the ground if you consider the person's height. About the second video about trig, which is about finding angles and using trig in word problems. You should have in your possession a practice packet which has all the final answers on the back. If you are not given this yet, please ask the sub for it. You have the rest of the period to work on the practice packet, and it is due tomorrow, and I will be taking a look at that. All right, guys, best of luck on the packet, and I'll see you tomorrow. Thank you.